In this tutorial, I want to show you how to use Google Spreadsheets for your data analysis, and we're going to do some very limited analysis for now and build stepwise into some more complicated analysis. So if you look over your lab objectives, which you should already have done before you collected your data, you were using you were measuring different scalars. Those two scalars in this case were volume and mass, using the appropriate tools, units, and uncertainties. Because the lab was highly directed, you were using the right tools of an electronic scale and water displacement for volume, which is probably the best way to do it, but inherently there are problems with this method for the items that you're measuring, and I hope you recognize those items. There are, you're hopefully using the correct units, and uncertainties are something you should include, but if you don't understand what those are, that's okay for now. We're going to if you can't put that into your lab report, that's fine for this lab, but it is going to be something that's expected once we talk about it in class. You need to be able to calculate means and standard deviations and complete t-tests. Although the t-tests we're going to probably save for later. In this video I'm going to show you how to calculate means and standard deviations. You may already know how to do these, but I'll show you how to do that in Excel, and then also interpret the statistics computed for statistical significance and other meaning beyond that once we have those values, and identifying limitations of experimentation beyond human error, and then identifying procedural improvements for each limitation. These are the expectations of this lab, and all labs really, but we're going to take a few steps to mastering a few of these skills today. So you've gone through your procedures, you've collected your data, and and you found your way here to the video that the lab report mentioned. So you should find in your shared drive the spreadsheet called number 3B, measurement lab data. It's going to have your name in the title, and mine has already started to been populated. So, and these are by no means numbers that I expect to see in your lab reports. These are numbers that I have made up for the purposes of this tutorial. They're not realistic of your data at all. You should have replaced your bean type 1, 2, and 3 with the appropriate names of the beans, and have your data put in here. Notice I have 3 decimal places, despite the fact that the scale only gave me 2 decimal places, and that is really related to the uncertainty. If you're in physics, you know how to calculate or learning how to calculate your uncertainties. For our purposes, it's going to be half, plus or minus half of the smallest, plus or minus half of the 1 digit beyond the smallest one that we can measure, because that's going to be a rounded digit. So if our electronic scale gives us 2 decimal places, that means it's rounded to the nearest hundredth, so it's got to be plus or minus 5 thousandths. So if that doesn't make sense, we'll talk a little bit more about that. So I've got my data populated in, and this is very rough. I don't have all 10 beans. I only have 4 of my beans measured. And what I've done is automatically put in a formula so that I'm going to calculate my density by taking mass over volume. And so I'm going to scoot over to the right, and I've already done this for you for some of the cells. This is the process data of the mass over volume for bean type 1, bean 1, and I've done that for the others. I've not put that formula in. If you look here in my formula bar, it's blank. But if I go to this one, it's already got cell A7 divided by B7, which is mass over volume. And so you can put that similar formula into these, or you can go and calculate it out to 4 decimal places. Whenever we process data, we need 1 more decimal place. This is IB rule. So my previous data had 3 decimal places. Here I have 4. Another way to do this would be to hover over the box in the bottom right corner of my cell, grab it, and pull down, and it will pull the formula down. And it's giving me this because I actually don't have any data in for bean 5 yet. For bean 5. So you can pull that down all the way for all 3 columns, but you should know how to do this. Put in a formula as well. It's pretty straightforward. Just put in the equal and then select the cell, a slash, and then the other cell. So then what I did was I'm going to delete that because it messed up my other numbers. So I'm going to delete that and scroll down to my process data. What I did was created 2 rows, one for my mean density and one for my standard deviation. If you don't know what standard deviation means, I recommend that you look in the book. In chapter 1, I think it's in somewhere in 1.1.1 through 1.1.3. Try to understand that statistical analysis. If you have questions, come to class with them. So I calculated the mean for these 2 bean types. And again, this is data that I've just fabricated. That's not what I expect of your data. And then I've calculated the standard deviations. And the way I've calculated the standard deviation is that I've used a formula called STDEV. Because standard deviation represents the variation or the spread of data within that set, I put in the formula equals STDEV, and then I had to select all of the data points that I want it to use to calculate standard deviation. So, excuse me. So I calculated, you can see everything in this orange dotted line is in that formula. And then I just did the same thing for the next set for bean type 2, which again you have relabeled as whatever type of bean you used. So I'm going to show you how to graph at least these 2. In your graph, I expect 3 bars, one for each bean type, with error bars. And so in this video, I'm just simply going to show you how to set up a graph. In class or in a future video, we'll talk about appropriate labels for axes. So first thing that I like to do is, and again, I'm in Google Spreadsheet, so I'm going to collect my data of just my means and standard deviations and titles. So I've got these 9 cells. So when you're doing it, you should actually have 3 more. You should have these 12 because you have 3 bean types. But I'm going to select these and hit and copy them. So I'm hitting Control and C, or you could right click and select copy. We'll scroll over here to the right and throw it into the top. Oops. What I want to do is right click, paste special, paste values only, and there we go. Now it went out many more decimal places than I needed to, and it put a spaced column in here because I had to merge columns. So I'm just going to do a few quick formatting things. I'm going to delete this column, and then I'm going to select these 4 cells because I only need 4 decimal places. So let me show you how to do that. I've selected all 4 of these cells, and I go to Format, Number, and I want 4 decimal places. So I don't see any of those here. Oh, here it is. But if you don't see that here, you go to More Formats, Custom Number Format, and I want 4 decimal places, or you could change that if you wanted 3. But I want 4. So choose that, and I go to Apply, and there you go. Done. So, well, I'm done with formatting the decimals. So I'm going to select these, the headings, my means, and their value, the mean title and their values. I'm going to go to Insert, Chart. Google calls these charts and not graphs. And I don't want a chart that goes horizontally. Really what I want is a column. So I'm going to choose the charts and column, choose this guy, and it's already put in my data for the 2 bean types. If you've renamed your titles, which you should have, because bean type 1 and bean type 2 don't actually communicate anything to me, it doesn't tell me which bean is which, this will automatically be graphed. And we want to click on Customize, and this is where you can change the chart title. And I want you to go and give it a try. Show me what you think would be an appropriate title, an appropriate descriptive title of the data. And you can change the font, the background if you wanted to, some other features, and then you could change the axes. So the title of the axis, of the horizontal axis, or you can go to the left vertical and change the title, the min-max. Go back to the horizontal. You could change the colors of each series of bean type 1 or bean type 2 if you don't like the red or blue. And we need to add error bars. So that's the next step. So if I'm going to move this screen just... Actually, what I need to do is... I need to know what the error bars of standard deviation I need to put onto each of these two graphs. They don't have each subset of the population. Each bean type 1 doesn't have the same spread of data as bean type 2. So we need to put error bars that are plus or minus 1 standard deviation to show the spread of 68% of my data. So in order to do that, I need to not put a percentage, but a constant. So I need to add a constant. But look at that. It squished my graph up because it's got an extremely high standard deviation of 10. But that's not what I want. So, what I want, let me see if I can... Okay, I need to get back to the chart editor in just a second, right? So, let me go back to none so it doesn't mess up too much. Okay, I'm going to insert, and then scroll back up to move him. And this is what I want for plus or minus the error bars. So again, this is what I need. I need this 0.0248 for bean type 1. So I'm going to select that cell, Control C, copy it, and then go back to my chart. And then when I click on the chart, I get this caret drop down button. And click on that and go back to Advanced Edit. I'm in Customize and scroll down. I'm going to go back to my error bars and put in constant. And I don't want 10, I want 0.0248. So there's my, and I clicked outside of that for it to update. And so that looks a lot better. That means that the data isn't terribly spread out, which is kind of nice, but again, it's fabricated, so that was intended. And so now I need to hit update, and then I need to do the same thing for the red bar, or bean type 2. So I'm going to do that very quickly. I'll let you watch me do that. So I'm back down here, and I need to select bean type 2. Error bars are constant, and then replace that 10 with 0.0312 for my data, and hit update. Now I'm looking at this data, and it was intended to be so because the means are obviously very different, but that doesn't really tell us if the two populations are different, because there could be outliers in those populations that are influencing the mean so much so that it's an inaccurate representation of the population. So we need to look at the spread of the data, and that's where standard deviation comes in. So when we interpret this graph, we see that because the means are different, and because at those means, at those means, the standard deviations of the data, the plus or minus standard deviations of the data do not overlap. I hope you can see that in the graph. There's likely not to be a there is likely a significant difference between these two sets. Now, I said there's likely to be a difference, so you need to follow up with what we call a t-test, because a t-test is appropriate for two populations of data. If we had 3 populations, which you're going to do later with your 3 different bean types, we would be doing a different test called an ANOVA test. But this is what a graph would look like that would indicate that there is a significant difference between the 2 data sets. If these 2 bars were closer to the same height, and we actually saw that this spread in the error bar overlaps with this spread in the error bar, actually overlaps on the y-axis, then it would show that there's not likely a significant difference. It doesn't disprove that there's a difference, it just shows that there's likely not a difference. So you'd have to continue with a further statistical test. But this is one graphical way to see the differences between the groups based on statistical spread of data. So again, I want you to make sure that you get a graph that looks similar to this, but you're going to have 3 columns with 3 different standard deviation values. You need an appropriate, whatever you deem to be an appropriate chart title. That's more of a formative assessment to see where you are, to see what you think an appropriate chart title would be. And then you need to make sure you have your y-axis labeled. I didn't do that. And anything else that's appropriately labeled. So once you've done that, you're going to copy this chart. And these directions are written, so thank you for following along the video so far, because this is important. So go back to your lab report where you saw the 2 asterisks. Right underneath that, you need to paste your chart. Now it's in this Google Doc, and you're done. You don't need to hit save. It automatically saves. I can take it from you now. Okay? I think this is long enough. I hope that makes sense to you.